Hey all, today we're back in our autonomy perception module for an on-road robotaxi project. And what we're going to do is we're going to show how when you have a safety case that you've loaded into Saphira, 2662, 2448, 1349, 2419, any of these, and you maybe have imported this based on some upstream or downstream documentation you've gotten from your customer or your vendors, then you can use Saphira to propagate changes and observe diffs on that basis. So the way we're going to test that today is we have this default component that's loaded in this project for the perception module. And you can see that by default, it doesn't have any hardware components listed. So if we scroll down and we look at the fault model that exists below, there's only one system malfunction that shows up that is mapped to the general system. So that means that the HARA is also only fueled off of that one malfunction. So if we give the system details about the hardware components, or we change maybe the ODD definition, we'll get a whole bunch more guidance on both the faults and ultimately the HARA. So let's give that a shot. Let me go grab some components to paste in. Cool, here we have it. So the first set of components we'll paste in are the front camera, the side cameras, the radar, and the compute ECU. And these map well to the existing interfaces we've already defined here. Now, typically in a further demo, we would also add in here something like a thermal camera that adds another functionality to this perception module. Now you can see as soon as we pasted this in, everything downstream got marked as needing an update because suddenly these have changed. So what we're able to do is we're able to scroll to the bottom of the item definition, and we're able to hit generate FUSA workflow to start this propagation. Now, this takes a little while, and typically I do this in fast mode, so using GPT-4o Mini, which means that it runs in process and usually comes back within a few minutes. But I've already done that in this other page, and we can glance at what it did. So let's take a look downstream, and you can see all of the system malfunctions that it came up with. So it traces many of these malfunctions to a variety of the new hardware components that have been added. So there is, for example, physical damage to the sensor that is dictated for the LiDAR that was added. There are some camera level malfunctions. There are some CAN bus malfunctions, software malfunctions, etc. And when we look down at the HARA, you see traces of every one of these into particular malfunction IDs. Like this particular hazard, the failure to detect an oncoming vehicle during a lane change maneuver, traces back exactly to that one malfunction. These were all artifacts that we didn't see before, and you can dig a little bit deeper in the Saphira platform to see exactly why it suggested each of these changes and see why it had to change the original HARA. So you can use this on a whole bunch of the documentation that you receive from your vendors and from your clients in order to figure out if you're actually meeting everyone's safety responsibilities and if everyone is meeting your responsibilities. So this is a little bit of what you get right now. You can see this all the way down, all the way through the safety goals and the FSRs, all the way down through the failure analysis, which right now is performed generically rather than using the key, the standard dependent failure categories, although this one looks pretty good. And it determines the ASIL levels of each of those in order to generate our safety mechanisms and technical safety requirements. This one's actually skipped right now because we have a little bit of different tracing that has to happen here, but we do definitely get some system design. We definitely get, if we scroll down, a bunch of implementation details that are traced back that can be tracked with your verification validation. You get a bunch of test plans that come up right there. And ultimately, you get your safety case, which is some set of claims and evidence as it's entered upstream. Great, there we have it. That's a little bit of how Saphira can build up change propagation through an existing safety case that's been imported based on changes to the hardware or the ODD. Makes your life a lot easier as a safety engineer. We'll quickly glance at a couple of other things that might be relevant. For example, because 26262 is selected in this project, there are a bunch of project deliverables that are already configured, like the technical specification, the safety test report. If we scroll down, it's the compliance matrix, depending on exactly what the system is. And as always, you can click in and you can use Saphira's document generation to prepare all of these to include in your case. Saphira manages all of this centrally, and you get a fantastic product that you can continue using for many different clients, many different use cases consistently.